morning, sir.
Okay, so yeah, I think that like very few people are here. Am I having like my voice is very clear, right? Like it's audible and no disturbances, right?
Yeah, sure.
Okay. Okay, only 10 students have joined. Like typically is the same because I think this is the first time I'm taking the session. So previously I think Prashant have taken the session. Two sessions he has taken. So okay. So shall I wait for some time or shall I start?
Sir, I guess if we can wait for 5 minutes, I think more people will join.
Okay, then let's wait for some time. Have you covered anything in statistics, like probably random variable related stuff? Okay. No answers? Okay. So this you guys are direct into diploma students, right?
Yes, sir.
Okay. Okay, wait for some time.
Hello.
Hi.
Hi.
Uh, yeah, so I was actually waiting for some students to join, but I guess like is it the same attendance you'll get in other sessions too? Because I'm not sure. This is the first time I've joined the session, that qualifier session. Previously Prashant have taken the two sessions, and I think he has covered until week 5 or 6, like until some questions from permutation combinations, right? Or maybe probability, I guess so.
No,
So
sir.
yeah,
He has not started probability till
okay,
counting principle. Prashant sir has covered.
okay. Okay, so let's like, because so I think it's like a lot of stuffs to finish it off. So what I'll do is maybe I'll start with some questions and we'll start them. You guys have to solve along with me so that it will be somewhat faster. And if any doubt is there, just let me know. Okay. Okay. Just wait. Yes. Okay. Just a minute. I'm sharing my screen in 2 minutes. Okay. Okay. So my screen is visible, right?
Yes, this.
Right. So I'm not sure. Like we have completed. I think he has completed only, let's say, counting principle or something. So I'm not going into the details of like I'm not going concept wise because it will take a lot of time and we do not have that much of time. Let's say we have 2.5 hours maybe or 2 hours after this. So let's try and finish it off like as we go with the questions. At the same time, I'll explain the concept there. Okay. So this is the question. Five dice are rolled
Sir,
simultaneously.
sorry to
Is this question
interrupt you,
completed?
sir.
Yeah,
Sir, till five question he had completed.
completed. Okay. So this vertigo and is it finished? Huh?
Yes.
Okay. Are we there with sixth question, right? Okay. So
Hello,
okay. I
Mayur.
think yes.
Yeah, Mayur, where can I get the PDF questions? I mean, yesterday some people were discussing questions from a
Okay.
different PDF of weekly PDF where uh, different weeks questions were there. So I just
Where
wanted to get those
where like
questions also.
which subject? Because yesterday there was no subject for
Statistics,
statistics.
statistics,
Uh,
or statistics and maths on both. I think both classes were held yesterday. So
no. For DAT qualifiers, we do not have. You are from DAT qualifier student or you are?
yeah,
Uh,
I'm that qualified.
So there was no DAT qualifier session for statistics yesterday. It was there on I think last Wednesday, right?
Okay, okay.
I'm not sure like
Yeah,
which.
but actually I was watching it from YouTube, so maybe it was
No, that was
previously
term
recorded.
students. Maybe yeah. No. There are some sessions going on. If
Oh,
there was a session in which the probability distributions were talked about, that was a
mhm.
different thing, right? Maybe you watched through online like IIT online degree page and from the YouTube, right?
Yeah, yeah,
And
from
I was
YouTube.
I was I was taking the session yesterday, and that was a different session. And the questions we were discussing they were different. Okay.
Okay, so can I get? Can I get those questions also?
Those questions we cannot share with that qualified students actually. Okay.
Okay, no
Fine.
problem. Thank you for the
Okay.
information.
So the question 6 is the shopkeeper wants to arrange four dark chocolates, two milk chocolates, and two white chocolates in a row at the front counter. Okay. In how many ways can he arrange the chocolates if all the dark chocolates are to be placed together? So yeah. So how many total how many chocolates are there? Eight, right? Eight. So that means we have to fill how many places? Eight places, right? Right? Is it correct? So fill the places. That means we have to arrange the chocolates in such a way that uh, this eight chocolates should be there, and there is a condition that he has to arrange those chocolates if all the dark chocolates are to be placed together. So that means how many dark chocolates are there?
Four.
Four, right? So these four dark chocolates should like they should be always together, right? That means if I have dark chocolate here, I cannot have dark chocolate here, here, and here, right? Because they are not together now. So they have to be together. That means either they should be like this or like this, right? correct? So consider these 4 dark chocolates as one unit, right? I'm not able to hear you. If you can go into the proper connect. Okay, okay, sorry. I'm not able to hear you. I don't know. Like others, are you guys able to hear Ajit?
Yes, sir. We are able to hear you, not the guy who's
Ajit, right?
speaking.
Okay,
His
Ajit,
voice
if you
is
wanted to
breaking.
say something, you should go into the proper internet connection and then because we are not able to hear you. Okay, fine. So yeah, so consider these 4 dark chocolates as one unit, and then okay, remaining. So how many remaining chocolates are there? 2 plus 2, 4, right? Correct. So consider these 4 as one unit, and the remaining chocolates are 2 white and 2 milk, right? Right. So
Yes.
total these are 4 chocolates, and this one unit. So that I'll consider as 4 plus 1 as 5. So what are the ways in which I can arrange these 5 chocolates or 5 units? Maybe I'll say how many ways I can arrange.
Five
So let's
factorial.
5 factorial, right? 5 factorial, right? 5 factorial. And as we have considered these 4
Four
chocolates
factorial.
as one unit, these chocolates can be internally arranged in how many ways?
4 factorial.
4 factorial ways, right? So these are the total number of ways in which I can arrange the chocolates. Okay. Uh, okay, I think this answer seems to be different, but okay, why we'll see. Maybe since these two, okay, okay. So this is a way. These are a number of ways when these all chocolates we are considering as a distinct chocolate.
Similarity.
If we are considering these 4 like all 8 chocolates different meanings, D1 D2, like say like if there are 4 dark chocolates, right? If I'm considering them as different, then these arrangements will be different, right? D2 D1, maybe D3 D4. These are the different arrangements when we are considering these all chocolates are different. But if you are considering them as as the same chocolate, like if I interchange these two, then also the if the order does not change, in that case there are how many ways then? Okay, 5 factorial ways divided by, since these 2 white chocolates are same and these 2 milk chocolates are same, it is 2 factorial into 2 factorial. Again, what I have to do? Is it right? Or should I divide it by 4 factorial as well? Okay, I'm not sure. Like you guys are not
Sir, I
answering.
think we don't have to divide by 4 factorial.
Correct, correct. We should not, because we already have considered them as
Because
one unit only.
ஜன்னல் சைதிக்கான்னு பாத்துருப்போம் பெட்ரூம்ல சமையல் கட்டுல கொசு வருது நீ கொசு ஊர்பட்ட கொசு எனக்கு கிடைக்குது சரி சாத்திட்டு போ
Okay. So do you understand what I'm trying to say here? Like why this is the correct answer and why not this correct answer?
Can you repeat?
Okay, fine. So let's say, okay, maybe I'll try to show you in some other way. Okay, so let's okay. So consider, let's say we have, I'll tell you, like maybe I'll tell you in a different example. For example, let's say we have, let's say these 4 chocolates, D1, D2, D3. Okay, let's consider only three chocolates. Okay, 3 dark chocolates, and I'm saying that these are 3 different dark chocolates. Okay, maybe from the 3 different companies. So I'm considering them as 3 different chocolates. In that case, how will you arrange these chocolates? So one arrangement will be like this: D1, D2, D3. What will be the another arrangement? D1, D3, D2, right? What will be the other arrangement? Let's say D2, D1, D3, then D2, D3, D1, then D3, D3, what is it? D2, D1, and D3, D1, D2. So how many arrangements are possible here? If these three are distinct chocolates or different chocolates, 8, right? Or 6, sorry, 6, right? These three plus these three. Total 6 number of ways I can arrange this. So what does that mean? Let's say we have 3 places to fill in, right? So first place I can actually have 3 options, right? Either I can place it D1 or D2 or D3. So 3 ways. If I used first place, I have selected one chocolate here at this place. Then how many or ways or how many chocolates I have to fill in here? 2, right? Because I have already used one previously and then 1. So this is 3 factorial ways, right? Okay. So what is 3 factorial ways? Again, these are the 6 ways, right? And which we have proven here. But consider the another scenario where I say all 3 chocolates are from one company. For example, they are from, let's say, Dairy Milk. Okay. So D1, D2, and D3 are the same chocolates. Okay. And I consider them as D. So how many ways I can actually uh, arrange these chocolates? How many distinct ways are there?
There are only one ways.
One way, right? D, D, and D. Because if I interchange anything, so let's say I said like this, again the same thing, right? So there is only one way. Okay. So this is one way. So how can I how can I with permutation, right? Or with permutation formula or with combination formula, how can I write this, like, or how can I achieve this? It is like, so suppose there are, in general, if they are the 3 distinct quantities or entities, in that case there are total of 3 factorial ways. And since these 3 are same, I'll say I'll divide it by again 3 factorial, right? And that will give me one way. Why? Because these 3 are same, so I'll just I'm removing those 3 factorial arrangement again, and that is becoming one way. So I'll give you one more example for this. Let's say I have, you know, uh, okay, this is the name Amar. Okay. How many letters are there in Amar?
4 letters.
4 letters. Okay. So suppose these were 4 different letters. Suppose these were some distinct 4 letters were there. How many ways I can arrange these 4 letters to have like meaningful or meaningless words? So there are a total of 4 places, right? 1, 2, 3, and 4 places. So first place I can and without repetition. So in that case, I'll say first place. How many? What are the choices I will have? 4 choices, right? Correct.
Yes, sir.
Right? What about the second? 3
3 choices.
choices, 2 choices, and 1 choice. So how many ways? This is without repetition. So all of this I am actually talking about without repetition case. Okay. So how many ways are there? 4 factorial ways in which I can arrange 4 letters so that I'll get like meaningful or meaningless words. Okay. But in this case, Amar, in this word Amar, A is repeating twice, right? So if I place this A at the first place and this A on the third place, uh, will this meaning change here?
No, sir.
No, right? So that means this arrangement and this arrangement, they are same, right? So what I have to do here now to get the correct number of arrangements, I have to divide it by 2 factorial, right? Because A is coming 2 times. So I'm just dividing those two combinations, 2 factorial, so that I will get the correct number of ways in which the the distinct words can be formed. So here it will be, how many words will be the 3 into divided by 4 you can
Your voice is
you wanted, let's say I'm considering this, okay, sorry.
Sir, your voice was breaking.
Is it fine now?
It's still breaking,
Is
sir.
it okay?
For me, it's breaking. I don't know for
no,
everyone.
breaking.
Is breaking, huh? Okay, currently now tell me, is it okay?
Yes,
Yeah,
sir.
now it's coming.
Now it's better, right? Okay.
It's
So,
better, sir.
okay, fine. So consider this A1 and A2 as two different A1 and A2 as a distinct letters. Okay. So what are the possible arrangements? I can write it down. AM, A2 R, right? A1, M, A2, yeah, A1, M, what is it then? Uh, okay. R, M, A2, A1, A2, RM, A1, A2, MR. That's it, right? Here, starting with A1, that's it. So suppose I'll say A2, okay, A2, uh, then M, A1R, then A2, M, R, A1, A2, RM, A1, A2, A1, RM, A2, A1, MR. So you see, 1, 2, 3, 4, 5. These 5 are the same
Sir, I
arrangements. Like,
think there will be one more letter for
no, there
first.
are no. We can have more arrangements with starting with M, then starting with R. Okay, so I'm just okay that I understand. So let's say we'll have like uh okay, how many 4 factorial means like total of 24 arrangements I can get actually, right?
Yes.
Right, but here this A1 and A2 are same, right? So what I'm trying to say is this 5 or this 6, this 5 are the same as the of this 5, right? Correct?
There will be
Correct.
six, I
So,
think.
okay, whatever. Like I'm see, this is for example. I'm not writing down all the things. This is for you to understand. Like, okay, whatever I'll write with A1 A2 combination, uh, these two arrangements. What I'm trying to say is these two arrangements, right? This A1 A2 A1 M A2 R is same as that of this, right? So I have to remove one similar arrangement since A1 and A2 are not the different letters; they are the same letters. So if there are 24 total of 24 ways to arrange 4 letters in a word, what I have to do is I have to divide it by 2, right? Because 2 is happening 2 times. So the number of ways in which I can arrange these 4 letters uh, will reduce to 12 instead of 24, because whatever you will write with A1 A2 differently, these two will be the same things. So I am just cutting it down to half, and that half is actually 2 factorial. So if you have 3 similar letters in the word, what you have to do, you have to divide it by 3. So for example, I'll take one more example. Let's you guys tell me. So let's say okay, any okay, my name is not there. What else is there? Okay, let's say this arrangement. Okay, in how many ways you can arrange the letters in this word? Again, I'm talking about without repetition. How many ways you can arrange form the words such that uh, these words are distinct and What is it? They should be, they can be meaningful or meaningless. Can you tell me the answer? Okay, how many letters are there in this word?
11.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So, if I wanted to arrange these 11 words, how many number of ways are there? Total number of
11
ways?
factorial.
11 factorial. And okay, so here, what is repeating? A is repeating. A is here, right? A is here. A is repeating how many times? 2 times, right? So I'll divide it by 2 factorial. This is for A. R is repeating how many times? 2 times. So I'll divide it by 2 factorial here. E is repeating again how many times? 2 times, right? Correct. So I think that is it, right? So you can think of like how many distinct letters are there? A, R, N, then G, then E, then M, and then T. Right? 1, 2, 3, 4, 5, 6. So 7 distinct letters are there. So A is repeating 2 times, R is repeating 2 times, N is repeating 2 times, and E is repeating 2 times. So I have to divide it by 2 factorial again. And these are the number of ways in which I can arrange the letters to form the, uh, the to form the words, right? So in our case, the dark chocolate case, what was it? There were 4 dark chocolates, 2 milk chocolates, and 2 white chocolates, and I have to arrange these chocolates in such a way that these 4 dark chocolate should always be together. So these 4 dark chocolates, I am considering them as one unit. So total of how many units are there now? These 2 white chocolates plus 2 milk chocolates plus 1. So there are total of 5 units, suppose, right? So in how many ways I can arrange these 5 units?
5 factorial.
5 factorial ways. But again, in this case, 2 milk chocolates are there and 2 white chocolates are there, and they are the same kind. So if they are of same kind, then what I have to do here? I have to divide it by 2 factorial and 2 factorial. Even though these 4 dark chocolates are also of same kind, but why I'm not dividing by 4 factorial here?
Because we are considering as a 1.
1 unit, right? So I have already considered them as 1 unit, and I'm not taking into count of that, those 4 uh, 4 different or whatever internal arrangement is there between these 4 dark chocolates. But suppose, let's say there are, okay, I'll tell you one more question. So let's say there
Sir,
are, yes,
sir, one doubt. Sir, if we do not take
yeah,
the 4 dark chocolates into one unit, and let's say we take the answer, we gave it as 4 plus 2 plus 2, that is 8 factorial upon,
okay,
and we divide by 4 factorial, 2 factorial, and again 2 factorial. Would this be right or not?
okay. What do you think? Will that be right or no? You tell me. So, okay, first of all, we'll write down the answer first, and then let's talk about it. Okay. So it is 2 factorial, 2 factorial, you get cancel. 2 factorial is 2, so it's 30, right? Okay. What about this? 8 into 7 into 6 into 5. This 4 factorial get cancel. Again, this is 4 and this is 2, right? So what is it? 10, 420. This is 420, this is 30, right? So why this is not true? What happened here? So we have counted those ways also in which these 4 dark chocolates are not together, right? See, uh, that is okay. You have divided by 4 factorial, that is fine. But the problem what happened here is 1, 2, 3, 4, 5, 6, 7, and 8. So here some ways are there, like I have just counted these things also, where these 4 dark chocolates are not together. So when I say
Okay.
8 factorial, in this 8 factorial, I counted all those cases where these 4 dark chocolates are not together, and hence that will not be correct thing, right?
Yes, sir. Got it. Got it.
Got it, right? Okay. So let's take a to okay. Okay. So you guys just tell me now, based on our discussion, just tell me the answer to the question number 7. Take 1 or 2 minutes to think and just let me know.
Sir, 7 factorial upon 4 factorial into 2 factorial.
Okay, that is one answer. What is our answer? 7 factorial upon
4 factorial into 2.
okay, fine. Any other answer? Just think about it.
So by finding the total arrangements minus
Hmm.
2 milk chocolates placed together.
Okay, fine. Think of it again. Is there any other way, or so there are four same thing is there. We have to arrange the chocolates if no two milk chocolates are to be placed together. So what you have to do first, you have to find the number of ways in which the two milk chocolates are together, and then you can subtract those from number of ways in which like from the total number of ways, right? That is one option, right? Correct or no?
Yes, sir.
Yes, sir.
So what are the total number of ways in which I can arrange these 8 chocolates?
8 factorial upon 4
8
factorial
factorial.
upon 4 factorial, 2 factorial, and 2 factorial.
These are the what? These are the total number of ways I can arrange chocolates, all chocolates, right? Okay. What about the number of ways in which two milk chocolates are together?
7 factorial upon 4 factorial into 2 factorial.
Right. This is the the case in which you know
2
two
chocolate.
milk chocolates are together. Okay. So if I wanted no two milk chocolates together, so that means what I have to do, I have to subtract these number of ways from total number of ways. So how will I do that? Minus 7 factorial upon 4 factorial upon 2 factorial, and that is what the correct answer. Is it correct? You understand the concept, right?
Yes, sir.
Okay, fine, good. So what about question number 8? So in a committee, there are 3 persons which has to be selected from a group of 4 men and 3 women for a position of president. Okay, there are how many positions are there? 3 positions, right? And how many total candidates are there? Total
7.
7 candidates are there. We have to fill 3 positions. Again, these 3 positions, you can see that there is an uh, like you have to fill these positions. That means there is an order, and if it is order, that means it's a problem of an arrangement. Okay. But the condition is if the president position can be filled only by a woman. Okay. So let's say there are 3 positions. Which 3 positions are there? Let's say this is president, this is vice president, and this is secretary. And I have how many options? 4 men and
Women.
women. So the president position can be filled by
Receive.
uh, how many ways?
Women.
Receive 1.
3C1, right? That means only 3. Okay. Okay. Right. So I can have, I can choose only one woman from these 3, because that is the condition which is given to us, which is if the president position can be filled only by the woman, right? Okay, good. So what about vice president position now? How many ways are okay? How
6
many
into
candidates will be
on left 6 men and women.
there, right?
Or
So I have already chosen one woman for the president positions. Now I have left with 6
6,
options, and I will choose one option out of that. And what about secretary now?
5,
5
3.
3 1,
Yeah.
right? And again that means 3 into 6 into 5, right? Oh, sorry, not 180. It's 90, right? Clear this simple problem? Yeah.
Mayur,
Yes.
so for the president position, 3C1, there are 3C1 possibilities,
Sorry,
options. For
there are
president
three
position,
options, right?
there
Yeah.
3C1
So
options.
hmm.
Now, for vice president and secretary, there are 2. So we have to choose 2 people out of the remaining 6 people. No?
Yeah, that is okay, that is true. So let's say 3 into 6 p2, right?
Yeah,
So 6p2 is nothing but 6 into 5. You can check. So what is
yeah,
6p2?
yeah.
6 factorial upon, what is it? 4 factorial. So this is 6 into 5 into 4 factorial. So this 6 into 5, right? The same thing, correct?
Okay,
So you can
okay,
either write 3 into 6p2, or see, that is whatever you said is correct only. So we have to choose 2 people, but that shouldn't be 6c2, right? That should be 6p2, right? Because okay,
okay,
you have chosen 2 people, that is true, that is good. But then you have to arrange these 2 people, right? 2
okay.
factorial ways. So this 6c2 into 2 factorial, it becomes 6p2,
6 people.
right?
Okay, fine. Yes,
Correct,
got
no?
it.
Yeah.
Yeah.
Okay, so the ninth question you may try later, because I'm is kind of the similar one. So I'll just share those. Do you have those PDFs with you?
No, sir.
Okay, I'll share. I'll ask them to share with you by today, or maybe by tomorrow morning you'll get that. So yeah. So okay, I'll leave this one. This you can try again, the same similar level of concepts. Okay. Okay, random experiment we'll talk about a little bit, and then I'll come to the circular permutation part at the end. It's not difficult. Maybe I'll tell you like briefly about it. But okay, about question number 13. So we'll just like we are going into the probability section. So let's say the question number 13 is, okay, what is probability? Generally, like how to find the probabilities for any kind of thing? We have to perform one random experiment. What is random experiment? You just you do like first of all you do an experiment, which is for example rolling a die. Why I'm saying this as a random? Because let's say, how many faces are there on a fair die, like a normal die? We have
6.
6 faces, and the numbers will be 1 2 3 4 6, will be written over there, or maybe the dots will be there. So there are 1 to 6 dots on the normal die. So when I throw, or when I roll a die, uh, do you like do you, okay, I know that there are 1 2 3 4 6. So if I roll a die, the outcomes can be 1, can be 2, can be 3, can be 4, can be 5, can be 6. But why I'm saying this as a random experiment is, even though I know what are the outcomes, I don't know what outcome will I get when I throw a die. Is it correct? I may get 1, I may get 2, I may get 3, I may get 4, I may get 5 or 6, or maybe I get like 6, right? Like let's say first I throw a die first, and I'll get 6, right? Then in the second throw I may get 1, in the third throw I may get 3. Or if you roll a die, you'll get, let's say, in the first throw 1, in the second throw again 1, in the third throw again 2. So the outcomes which I'm getting, even though I know the outcomes prior, the outcomes I'm getting out of it, out like whenever I perform the experiment again and again, the outcomes I'm getting are random, right? And hence it is called a random experiment. Right? So consider these experiments. What do you think? Which of the experiments are random? So the first experiment is selecting a family out of a given group of families. Is it a random experiment or not? So let's say we
Right.
have like it's random, right? Because we have four families. Maybe like let's I don't want to go, but yeah, let's say there are four families. One is from Rajasthan, one is from let's say Maharashtra, one is from Tamil Nadu, and one is from maybe Northeast. Okay, so these four families are there, and I'm just like I have blindfolded, and I wanted to choose one of the families, uh, and so selecting that family out of those four families, will that be a random experiment or will that be a normal experiment?
Random experiment, sir.
It's a random experiment, right? Okay, fine. What about the second one?
It's also
It's a random.
Random.
Right. So selecting a pack of cards. Okay, there are how many? What is the sample space in that case? In the second case,
52.
52, right? So there are like 52 outcomes possible, but every time I pick a card, I don't know what outcome I'll get. So that is again a random experiment. What about the third experiment?
It's absolutely wrong.
It's again the random
Random.
one. Okay, fine, correct. So now we'll talk about probability a little, and we'll try to solve the questions on the probability. So let's say two unbiased dice are thrown. What do you mean by unbiased?
They have
Unbiased
numbers
or
from
fair?
1 to 6.
Okay, and what about biased die then?
One number might repeat on in two phases.
No, it's not like that. So the difference between the biased and unbiased is each of the outcomes. So let's say I have thrown one dice, right? So I have already wrote down the sample space here, right? So 1, 2, 3, 4, 5, 6. So uh, when I say it's unbiased, right, that means the probability of each of the outcome is same. Okay. So let's say if I toss a coin, there is an head and tail on the coin. So if I say the probability for getting a head is 0.5 and getting a tail is 0.5, then that is unbiased or a fair coin. But when I say the probability of getting a head is 0.3 and probability of getting a tail is 0.7, then that is what? Biased coin. So do you do, okay? I'll just maybe I don't want to go there, but okay, it's for your like thought process. How do you get the probabilities generally? Do you know like how we assign the probabilities to each of the things? What is probability generally?
Number of, I mean, favorable outcomes versus
Number of
total outcomes.
attempts in time.
Yeah, the favorable outcomes or
Number of attempts.
Upon total outcomes. Total
yes,
itself.
right. So actually the probability is okay. This is a general definition of probability: favorable outcome divided by total outcomes. Okay, but is it like familiar to the relative frequency concept? Like, did you study
Yeah.
relative frequency? So what is
Yes, sir.
relative frequency? So if you do an experiment like lot number of times, and you'll calculate like what is, let's say if you throw a normal die, or if you throw a die for let's say 10 times, and you observed this, one is coming two times, two is coming three times, three is coming maybe one time, four is coming one time, three to five, five to seven, and five is coming let's say two times, and six is coming one time. These are the frequencies, right?
Yeah.
And what about the relative frequencies? This point two, point three, point one, point one, point two, and point one, right? This is two
Yes,
by
sir.
10, 3 by 10, like that. So if you do this kind of experiments for a longer enough of time, okay, and then you found out like then you say these relative frequencies as probabilities. Okay, do you understand? Like if I throw a die for let's say 1,000 number of times, okay, and then I noted down every relative frequency. I noted down the frequency of each of the outcome, and if I say now, based on this, okay, based on the outcomes, I told that okay, this is which we have observed, and then that becomes, that relative frequency becomes the probability in general. Okay, so okay, that like maybe you'll study that after like central limit theorem, and those concepts you'll study later, but generally the probabilities will be assigned like this. So when I say unbiased or fair die or fair coin, then that means each of the outcome will have what, equal probabilities. So what do you think in this case, if this is an unbiased coin, what should be the probability here? Getting
1 by 6.
1 by 6, 1 by 6. Yeah, so every outcome has the same probability, right? Correct. It's 1 by 6, 1 by 6, 1 by 6, 1 by 6, and again this is kind of a uniform discrete distribution. Okay, but that we'll see after some time. So this is the meaning of what, fair die. Okay, now just think about it. Two unbiased dice are thrown. Find the probability that both the dice show the same number. Okay, so can you tell me one thing? Okay, maybe I'll just write it down. If you can tell me what should be, so if I throw two dice randomly, or maybe thrown two dice or roll two dice, what should be the expected outcome? If I wanted to write down the sample space, what should be the sample space?
36.
Yeah, so what it should be like, the
1
number of
1
elements
1
in the
2.
sample space are 36. So it is 1 1 1 1 2 1 3 5 1 6, right? Again this is 2 1 2 2, and this 2 6, 3 1 3 2, this is 3 6, 4 1 4 2 4 6, 5 1 5 2 5 6 6 1 6 2, and 6 6, right? So this is my sample space. Like how many numbers are there? So number of elements in the sample space are 36, right? What one represents here?
Outcome
Both
from
the
the first
dice,
dice.
First die,
both the dice roll to 1.
and this is yeah. So okay, so first number represents the outcome on the, or the first die, and second number is outcome on the second die, right? Okay, correct. So now the question is what? Find a probability that both the dice show the same number. Okay, okay. Which are the outcomes? I told you like have the same. So which are these outcomes will be? So these are diagonal elements, right? They show the same number. So what is it? Like how many are there?
6.
So the probability is what are the favorable outcomes here?
6.
And what are the total number of outcomes are here?
36.
30. So the probability is 1 by 6, right? Like this. So I can actually write it as correct. Is it okay? All of you understand this?
Yes, sir.
Yes, sir.
Okay. Good. So yeah, that is fine, and that is the correct answer. Okay. Fine. This is this familiar to you? The question number 15. Okay. Okay, fine. I don't know like if you guys know this or not. What is probability of A union B? Do you know the Venn diagrams? Like, are you familiar with the Venn diagrams?
Yeah, it's I
Yes,
think
Yes,
sir.
sir.
probability of A plus
Yes, sir.
probability of B minus
So if
probability
this
of
is
C.
union, so this is probability of A plus probability of B minus probability of A
A
intersection B, right? Is it correct? So if you think of like this, so let's say there are two events. If I wanted to show it through Venn diagrams, this is A, this is an event B, right? So what is A union B? This is red portion, correct?
Yes.
This is A union B, right? Everything in sets A and B. Okay. Uh, okay. So this red portion was A union B. What is A intersection B? Which portion?
Common portion.
This portion, right? So what about this? Probability of A plus probability of B is what? So what is probability of A? This portion, right? This green colored portion is probability of A, correct? Or I'll say, think about it like number of elements in A. First of all, don't think about probabilities in this at this time. But okay, but again, it is going to represent again this like if you divide it by total numbers, it will represent the probability only. Okay, so probability of A will consider this part, right? The green portion. What about probability of B? This one, right? This portion. So what is happening here? This portion, right? This one, this this middle portion. This actually we are counting it two times, correct? When I say probability of A, that will also count that middle portion, and when I add probability of B, then again that middle portion is coming again. So, but probability of A union B should have only one that portion, and that's why we are actually subtracting that portion, right? Do you understand this one, this part?
Yes, sir.
How this formula comes? Okay, so when we are talking about, okay, this was for the two events. So let's say there are three events: A, B, and C. So A, B, and C. Okay, which, so when I say, okay, what is probability of A union B union C? All the portions, right, inside this, correct? So this should be like this, right? Everything inside. Okay, so if I add probability of A plus probability of A plus probability of B plus probability of C, what is happening now? Which portion I have to like? Okay, when I say probability of A, then what happens? This portion will also come. Sorry. Okay, so I'm just when I say probability of A, then this portion is coming. Probability of B, then this portion, right? And probability of C, then what is happening? This portion, right? So what I am doing, like what is happening here? We are actually counting those common portion three times. So which portion I should subtract now to get probability of A union B union C? Probability of A intersection B, right? This is okay. So maybe I'll just clear out the colors. What is probability of A intersection B? Which portion? This one, right? This probability of A intersection B. Okay. So I'm just subtracting this probability of A intersection B. What is probability of B intersection C? Which portion? This one. Probability of A intersection C is correct. So if I subtract these three, probability of B intersection C, probability of what is it? A intersection C. Okay, so is it going to become probability of A union B union C, or should I add or subtract anything else?
So the middle part is not added right now, as of now. The intersection of all the three A, B, and C.
Right. So what I have to do? I have to add one more portion, right? Which is this one, which is common to all three, right? This portion, because we have subtracted it two times, right? Like while actually subtracting this one, and this one, I have subtracted this that one like that many times. So what I have to do? I have to add that one. And what is it? Probability of A intersection B intersection C. Okay, and I think that is a formula. So now tell me, with this given information, can you find this value? But I don't know, like, whether it is needed or not, but just think about it. Whether this information is needed or not, I'm not sure.
And sir, I think we can find it from the above formula only,
Okay.
without using the three
Are you
elements
sure?
formula. Yeah, sir.
Okay.
Can we take A union B as another element, such as D, and then we put all the values and find the answer?
Think
I
about it.
found,
You just find out, no?
sir, I did. The answer is coming 0.1, but I'm not sure it is correct or not.
Okay. How do you find out that it's 0.1?
Sir,
Okay.
I first of all I took A union B as another element like D,
Okay.
and then
Okay.
I substituted all the value in the given information.
Okay. So you did like this, right?
Yeah,
For
right.
the but probability of D, that means it is given as zero 0.5, correct? Probability of C is zero
Yes.
point 0.2. That is fine. But what about this?
So this we have to find. This is the
From where?
value we have to find.
Okay.
So the
From where
question
you?
is this.
Yeah. So you need to use this information, right? I don't like think about it once, or like any other way is there?
Sir, the formula is starting with D union C. So
Okay,
that
you think about.
value is given.
Okay, so you are saying that it's probability of D union C is given, so it is probability of D. So probability of D union C is given as 0.6 is equals to probability of D is what? 0.5 plus zero point 0.2 minus probability of D intersection C, right? So it is 0.5 plus zero point 0.2 is 0.7. So probability of D intersection C is equals to how much? 0.1, right?
Yes, this is how I found
And
it. Yeah.
correct. And then okay, I think A union B. I don't know. Like this is not required. Anyway, directly 0.1. Correct. Right. All of you understand this? Like how we have approach to this answer? If not, just
Yes.
tell me. Okay, I only two or three people are speaking. I don't know.
Yes, sir.
All of you understand?
Yeah, we got it. We got it.
Fine. Good. Okay. Okay. There are like a lot of questions. Which one I should take? Okay. Then let's just think about this question number 16. I'll just come back. I need to uh, charge this one, right? So I'll take the charger up, and until that point of time, just you just answer this question number 16. पानी थी क्या मेरे पहले? Am I audible?
Yes, sir.
Okay. What is the answer? Okay. I don't. Okay. Let's approach this question like this. Suppose okay, we have an urn, right? 6 white ball, 4 red, and 9 black balls, right? Fine. Simple one. So suppose you have this urn, and how many white? We have white balls, we have red balls, and we have black balls. So how many white balls are there? 6, 4, and 9. So 6 white ball, 4 red balls, and 9 black balls are there. And how many balls you have chosen randomly? 3 balls are chosen randomly, and that is without replacement, right? Okay. So if it is that without replacement, what does that mean? What does it mean? So
Let me choose
when
one
let's
ball.
say
It
three
will
balls are chosen, right? So let's say if I pick one ball, then okay, currently how many total balls are there? 19, correct?
be yes.
Okay. So if I pick one ball out of it, so how many balls will remain there?
18.
18 balls will remain. Okay. Then if I don't replace that ball, uh, so what will happen? The number of balls will remain 18 in the urn, right? And then if I again choose one ball, then will remain with how many balls? 17. Is it correct?
Yes, sir.
Okay. So and if I choose one more ball, how many balls will remain? 16, right?
16.
So the probabilities will be different, right?
Yes, sir.
Right. So if the balls are not replaced, in that case the probabilities will be different at each draw. Correct? I think that is the meaning of it. And the question is, then find the probability that one is of each color. So suppose if I, okay, I'm not sure like how they have come to this answer. Okay, let's try it out. So suppose each I need to check like, okay, suppose, okay, what will the possibilities if I have first I drawn white ball, then I can choose red ball, and then I can choose black ball. This one possibility. Then there is, if I started with red ball, the next ball is white, and the next ball is which one? Black. Maybe I started with black. I will have uh, what, white, and then I will have the red balls maybe, or some other combination. So how many combinations are possible here, where each of the balls is different? 3 6, right? 3 factorial. I don't know, like I'm not sure that whether this question means the same thing, because it is becoming difficult. If I wanted to find it by, okay, let's think about this. I'll remove this word without. So if I say with replacement, then what will happen? What will be the probability then? So I have 6 white balls, 4 red balls, and 9 black balls, and I have chosen 3 balls randomly out of it. And I wanted to find the probabilities that each of the ball is of different color, or that the one is of each color. So first of all, tell me, out of this 19, okay, what is probability generally? What was our definition? It was favorable outcome upon total outcome, right? Right. So what are the total outcomes here if I wanted to choose 3 balls out of the 19? So that is 19C3, right? And if I say it's without replacement, with replacement, that means every time I see the ball, I'll check the color of the ball and I'll keep that ball inside the urn again. So again, when I say when I found out the next ball, it will have the same, you know, uh, number of balls in the denominator, or not in the denominator, in the urn. So for example, let's say here we have 6 white balls, 4 red balls, and 9 black balls. I can find, uh, okay, what are the favorable outcomes here? The numerator, 6 C1, 4 C1 into 9 C1. So it may be like, in the first, let's say 6 by 19 into 4 by 19 into 9 by 19, right? So that is also the same probability. You can check whether it is correct or not. And this I can do it for how many times? 3 factorial times, right? Because there are 3 positions maybe here. So I can see that uh, I can choose white ball first, I can choose uh, black ball first, or I can choose red ball first. So there are like 6 probable 6 possibilities. So it is 3 factorial, and if you check this answer, it will again be the same, because you see it is, okay, whether, yeah, this is without replacement only. Fine, that is okay. Mm, 17 by 3 factorial. Okay, fine, that's correct. Okay, so okay, this is the answer for with replacement, and this is for without replacement. Okay, what is do you understand this one, or like if you want me to explain it again?
But the answer is coming 0.11, not 0.22.
With which one? Without without replacement one. So I told this is
That
without replacement.
with the combination one, C6C1 plus
Mhm.
it's coming 0.11.
Sir, it's coming 0.22 for
0.11.
me.
Okay, just check the calculations again. It should come as 0.22. But do you understand this one, or like do I need to explain it again? With or without replacement factorial?
Kindly explain it once again, the without replacement one.
Okay. So with replacement, case of two colors, okay? That thing into the 3 colors. So for example, let's say you have, let's say, 5 white balls and 2, let's say, blue balls. Maybe or
Sir, your voice is
red
breaking,
balls.
sir.
2 randomly. Now I'm saying, I'll say it's okay. So in that case, what will happen? Let's say I have, and I wanted to see the probability that both the balls are of different color. Okay, that is my question. Now tell me, if so it can be either white, correct? Am I audible? Hi.
Sir, your voice is breaking way too much,
Hello.
and whatever you said until now, we didn't hear it.
No, I was like waiting for you guys' response. Is it clear now? Is it clear?
Sir, now it is clear, but whatever you said until now, it's not clear. We
Okay.
didn't hear any
No,
of it.
okay. No, I in between I didn't speak actually. Okay, fine. So there is like white ball, and so okay, the first ball can be what? It can be white or red, right? If I choose two balls randomly, and that is with replacement, I'll tell you. So if I choose first ball, it can be white or it can be red, correct?
Correct.
Okay. So what is the probability that it is white? Yeah, fine. 5/8,
Yeah, right.
correct? So suppose the if I wanted to check, if I wanted to see that these two balls are having of a different color. So now I said that this is white ball, okay, and this is the probability of getting a white ball. Okay, fine. So now tell me, and with replacement means what? So when I chosen the first ball, how many balls? Currently there are total of 8 balls. So when I chose one ball here, how many balls I left with in the urn? 7, correct?
Yeah, right.
But now when I say with replacement, that means I have checked the color and I have just kept that ball again back to the urn. So now how many total balls are there? 8, correct? Is it okay?
Yes, sir.
Okay, so then next time I have chosen the second ball, and it can be red or it can be white again, right? So
Yeah, right.
suppose this is a red ball. Second ball is red. What is the probability of getting a red ball? Is it 3/8 or 3/7?
3/8.
3/8, right? Do you understand this? Why? Because I said it's with replacement. But when I say without replacement now, without replacement, okay, in that case, when I chose the first ball, what is the probability that it is white? 5/8, right? This is how we reach to the concept. It is because 5C1, I have chosen one ball out of it, and out of this is 8C1. So this is 5/8. Okay. But how many balls are remain there in the 7? This is 8 minus 5. Okay. And I did not replace the ball into the urn. So that is without replacement. In that case, what will happen when I choose the second ball now? And if that is red, then what is the probability that it's a red ball? So there are total of how many red balls are there? 3, right? So it is 3C1 divided by 7C1 or 8C1. Hello.
Yes, sir. Yes, sir. Hello.
Okay. Hello. Hello.
Yes, Mayur.
Yes, sir.
I'm audible, right? I'm audible, right? Like,
Yes,
I don't know,
completely.
like
Clearly
nobody's
audible.
answering. So, okay. So, okay, what is the probability that it's a red ball? When I say it's without replacement, then it should be 7C1, which is 3 by 7. Okay. So, this is the difference between with replacement and without replacement. So, okay, what are the now what are the possibilities? We'll check it out. Okay, with these two uh, conditions. So, first of all, I'll check the condition which is with replacement. And when I say with replacement, that means what? Whenever I draw the next ball, that doesn't change the probability. At least it will not change the probability of uh, whatever we are doing. So let's say when I say okay, I need to tell you that not changing the probability is what. Let's say if I say without replacement once. So if the first ball if I chosen, and if that is white, then what is the probability that the first ball is white? It is 5 by 8, right? And then if it is without replacement, that means I'm not keeping that white ball again into that urn. And now I have chosen the second ball, and let's say that ball is again white. What is the probability that the second ball is white? So it is 4 by 7, not 5 by 8, right? Because I have already taken out one ball, and since the first ball was white, the second ball is 4 by 7. So these are the two now dependent events, correct? These are the two dependent events. So the probability that the two balls are of same color or the of white color, it is 5 by 8 into 4 by 7, which is you can say that it's 5C2 divided by I think 8C2, right? So if you can think about this is the correct answer. Okay. uh, what happened here is during each of the draw, the probability of getting a white ball is changed, right? uh, and this will happen when it is an without replacement. But when it is with replacement, in that case we'll see in that case what will happen. So suppose the first ball drawn is white, then the probability that the first ball is white is how much? It is 5 by 8. That is fine. But when I say okay, if I this is now we are talking about with replacement. So, and next time if I draw the ball and if it is white, then the probability of white ball is again what? It's 5 by 8. It's not 4 by 7, because the white ball we have seen the color and we have kept that white ball again into that urn. So the number of white balls again into that urn is 5. And the number of red ball, yeah, because we didn't pick up the red ball, so it is 3. So the total number of balls again are the same, and hence the probability is not changing when it is with replacement. Okay, and in that case the probability will be 5 by 8 into 5 by 8, right? 5 by 8 into 5 by 8. Okay, so that is a difference. Okay, one more thing you need to understand is now what are the possibilities when I say two balls are chosen from this. So first possibility is let's say this is first draw, and I'll say this is second draw. So when I say the first draw, it is irrespective of with replacement, without replacement. How many possibilities are there that we are checking now? Okay, so first draw can be white ball, second draw can be white ball. What is the second case? First ball is white, second is red. Third possibility is first ball is red, second ball is white, and fourth possibility is first ball is red and second possible is red. Right? These are the four cases which can be which are possible. So what? So if I say without replacement, now the question is, let's say without replacement, can you tell me the two balls chosen from this urn are white? Are white? What is the probability that two balls are white? Can you tell me? So which of the cases there? First case, right? First case, right?
Yes, sir.
So then what is the probability? it's, and this is without replacement. In that case, first ball white is 5 by 8 into second ball drawn is what? 4 by 7. Correct? Correct? What is the probability that two balls are red? This case, right? And the probability is what? 3 by 8 into 2 by 7. So, okay, and then I say, what is the probability that both the balls drawn are having different color? So, different color means which cases? These two cases, right? These two cases, because first ball is white, the second ball is red. First ball is red and the second ball is white. So let's find out the probabilities. So let's say what is the probability that it's white ball? It's 5 by 8 into red ball is what? 3 by 7. If the first ball is red, then in that case the probability is what is it? 3 by 8 into 5 by 7. Okay, so can I write uh, to this as, so for different color it is 2 times 5 by 8 into 3 by 7. This correct, right? Can I say it is 2 times?
No, sir, how can
I can say, right, because the denominator, so I'm multiplying these probabilities and denominators are same, right? 8 into 7, 8 7, and the numerators are also same, 5 3 and 5 3. So I can say like it's 2 times the thing. So why this is 2 coming here is because there are two possibilities, right? Two ways in which I can have the different color, but the probabilities are same here. Okay, so these probabilities I wrote it down here for what? It's for without replacement. Okay, so if I say now I change the question and I say that, okay, I'll remove these things now. I say then I'll say it's with replacement. Okay, with replacement, in that case, if I wanted to say, let's say two balls are white, what is the probability now with the replacement case? It is 5 by 8 into 5 by 8. Okay, what is the probability that two balls are red? So that is this case. Then the probability is 3 by 8 into 3 by 8, right? What about two balls are of different color? Different color. So it will be these two cases. First case, what is the probability? It's 5 by 8 into 3 by 8. Second case, it is 3 by 8 into 5 by 8. So I can say again, it's 2 times 3 by 8 into 5 by 8. So this 2 is what? The number of cases here. Okay, understood? So this is like number of ways in which I can choose. First of all, this number will represent number of ways or the number of cases where whatever is asked is possible. The second two things are what? These are the probabilities. In the first case it was 1 into this, here it is 2 times this, and here 1 into this. So similar logic if I wanted to apply here in our question, an urn contains 6 white, 4 red and 9 black balls. Can you tell me the answer now? So just I'll write it down. Okay, white, red and black, 6, 4 and 9. 3 balls are chosen randomly, and I wanted to see what, and this is what, without replacement or with replacement? This is without replacement. Okay, one more problem over there. Okay, sorry, it was okay. Again, this was without replacement. Okay, So the probability that one is of each color. So that means the three balls are different color. Can you tell me now quickly what is the probability that they are of different? So first, what we have to choose the color or a number of ways. So I think there are 3 factorial ways, right? There are a total of 6 ways, right, in which I can choose 3 colors, correct? So there are 3 positions. I have to choose in 3 factorial ways. Okay. Now, what are the probabilities associated with it? And this is without replacement. Can you tell me? So you can take any of the things. So it may be 6 by 19 into 4 by 18 into 9 by 17. Okay. So somebody can say that this is white, red, and black, or red. So somebody might say that I will take this probability red, blue, and white. Will this change? Will this change the answer or not? Let's find it out. So for example, this is for red. What is it? 4 by 19. For black, it is 9 by 19. For white, it is 6 by, sorry, it is 18 and 6 by 17. So if you see 19, 18, and 17, this is the same. Numerator is 4, 9, and 6. It is same. So the answer won't change. Okay. In this case, at least when I wanted to have 3 different balls. Okay. So this is without replacement. If I ask you the question for with replacement, what will you do? So it's same, right? Like 6 by 19, 4 by 19 into 9 by 19. And how many ways I can arrange these balls is 3 factorial. Okay, this is the answer. Just think about it 2 minutes and let me know if you have any doubts. Okay, so do you have any issues? No, right?
No, sir.
Okay, so maybe we have like limited time, so maybe I'll just keep these 2 examples. Try to solve this one and share this with you. Okay, let's talk about this question number 19. So this is the conditional probability problem. I'll try to explain what I can explain it
Sir,
in
there is still a
small
glitch
amount of
in the
time.
video, sir.
Okay.
You are explaining,
Okay.
and after 2 minutes, the written part is being shown to us, sir.
Okay. Okay. Fine.
There is
I'll
no
maybe
lag.
I'll
Actually,
start.
there is no lag from my side. I can see him
Fine. So
working.
think at the same time, right?
Yes, at the
Okay.
same
So
time.
maybe you can check the connections. Okay. Fine. So I think that it's not a problem from my side. Maybe you can check your connection. Maybe. Right? Okay, fine. So the question is, in population, 45% are female and 55% are male. Among all the females, 9% are left-handed, and among all the males, 11% are left-handed. If a person is randomly chosen from the population, what is the probability that the person is not left-handed? Okay. Uh, uh, I'm not sure. Like, okay, we don't have the much time to explain everything here. But let's suppose, do you know the conditional probability formula or Bayes theorem? Like, are you guys aware of this?
Yeah, I mean,
The
uh,
basic. Uh,
basics. Yes.
okay, let's say if there are two events A and B, okay, and if I wanted to find probability that A given B, right? That means what is the probability that event A will happen given that the event B is already happened. In that case, the probability is given by probability of A intersection B divided by probability of B. Okay, this is the common probability between these two, or like this is the probability that these two events are occurring simultaneously, divided by the probability of B has happened. So you can think of this probability of B is nothing but a total probability. Okay, I will tell you about the total probability later. So if there are two events A and B, and if I wanted to find what is the probability that A given B, so that means the probability that event A is happen. What is the probability that the event A will happen given that event B is already happened? So it is given by this, and this is a conditional probability formula. There is one more formula which is called the Bayes theorem. So Bayes theorem is, suppose there are maybe like more than two events, or okay, and in those events, so I'll try to draw it through the Venn diagram. Suppose there are, let's say, event A is
Sir, the
happening.
screen is stuck for multiple people, sir, not just for me.
Okay.
Yeah, now it's stuck. It's frozen over the question only.
Yeah. Now this thing, I just shared again. Just tell me. What is visible to you now?
Yeah, the question only in population.
Question and some diagram is there, right? So
No,
now
the
I have
diagram is
rubbed this
not.
diagram.
No, sir, no diagram, only question.
Okay. So what? Maybe what I have written here? No, it's not
Nothing.
visible.
We are only able to see the question.
Yeah, actually.
Okay, just okay. I'll check my connections. Okay, I'll try and rejoin again. Maybe let's see if that works or not. Okay, just a minute. Okay, so am I audible now?
Yes, sir.
Yes.
Okay, let's tell me like if my screen is visible to you or not. Is this fine?
Yes, sir.
The screen is visible?
Yes, sir.
Okay, so now I was talking about the conditional probability. So it was like probability of A given B is given by this probability of A intersection B and probability of B. So there is like uh, let's say we have, okay, I was talking about the Venn diagram, right? So suppose we have two disjoint events, okay, two or more disjoint events. Let's say currently I'll say that what is disjoint events?
Common elements is
Zero, right? So let's say this A and B are the disjoint events, but there is one in event C such that this, okay, so let's say this connects, okay, maybe, or this is having the intersection with these two events, okay. So suppose just draw the sequence like this, A and B, okay, and there is one element such that C, which is common to both the elements, right? So this is like this. So in that case, what is the probability of okay, the probability now it's given by uh, the Bayes theorem, okay. I'll tell you how. So suppose I wanted to find probability that C given A. Okay, what is the probability of C given A? Which part of this diagram shows probability of C given A? This portion, right? This red color portion is what? This is probability of A intersection C, right? And if I wanted to find probability of C given is it is what? Probability of A intersection C by conditional distribution formula. Probability of A given A intersection C divided by probability of A. Okay, what is probability of A? This portion, right? The entire thing. So this is probability of C given A. What about the second half? This portion. So that is given by probability of C given B, which is nothing but probability of A intersection C divided by probability of, sorry, not A intersection C, it's B intersection C divided by probability of B. So what is probability of C? It's a total probability, right? Probability of C means that intersection part. So that is nothing but uh, what? Probability of A intersection C plus probability of B intersection C, right? And what is probability of A intersection C? It is probability of A into probability of C given A plus probability of B into, from this equation, it's probability of C given B. So this is equation 1 and this is equation 2. From this equation 1 and 2, I can find out probability of C. This is called total probability. Okay, this total probability. Okay, so now if I wanted to find any one of the thing, so it is, let's say, probability of C given A. How can I find out this? So what is the conditional probability formula? General conditional probability formula, it is probability of uh, C intersection A divided by probability of A, right? Okay, sorry, I just wanted, okay, no, sorry, I just wanted to find, let's say, this one, probability of A given C. So in that case, I'll find out how. Probability of A intersection C divided by probability of C. Okay, and this is nothing but, what is probability of A intersection C? A intersection C is this one. From equation 1, it is okay. So this is called actually Bayes theorem, but that's Bayes theorem. But yeah, but generally it is probability of A into probability of C intersection A divided by what is probability of C? It's probability of A into probability of C. Sorry. So C given A. This is A plus probability of B into probability of C given B. So this is probability of A intersection C, and this is called as a Bayes theorem. Okay, this is the Bayes theorem. So there are two events A and B such that there is one more event C which occurred in both the events, right? In that case, I can find the probabilities of A with or A or anything like any event more than 3 events. So the generalized formula is, I think it's like this: AI, and I can go from 1 to whatever n is there, given that event C, which is common to all the events. Then in that case, it's given by probability of AI into probability of C given AI, or maybe the ith element or whatever is there, and then I can find the probability of C. And probability of C is the total probability, which can be given by like this. Okay, this is general Bayes theorem. Now let's talk about the question here.
Yeah, Mayur,
Maybe we'll
if I
yeah.
may ask something. Yeah, actually, I mean, if probability
Yes,
is
please.
basically, I mean, I think probability is just the proportion of total proportion of the outcome, the
Hmm.
or say the proportion the outcome occupies in the total probability space. So technically, I mean, if the 11% or of 55%, which is around 6.05%, shouldn't it be the probability of male left-handed person?
Which one? Okay, sorry.
11%
You're
of
talking about the question.
55%. Yeah.
11%
I
or
think.
huh.
Yeah, I think I was caught. I was talking about the 20th question. Sorry. Uh,
Huh.
so in that case, like that way, it should be 11% of 55%, which is like 6.05%. But the answer is clearly 6.65999.
Yeah, no, okay, I'll talk about that question. So if okay, I'll talk about the question number 19 first. Okay, see this whatever I have written here, it's like I'm just giving you the concepts behind there. It's in case you don't know the concepts, okay, or maybe the
Oh,
formulas.
sorry.
So
No,
we'll
no.
talk about question number
I
19.
understand that.
Yeah.
Sorry.
So the question number 19 is, in a population, 45% are female. Okay, 55% are male, and that is fine, right? So these are the two disjoint events that you are okay with, right? So suppose this is event A and this event B. So that means if 45% are female and 55% are male, that definitely means there is no common element in between them, right? Right? Is it okay?
Yes, yes, yes.
And let's say 9% are left-handed. So 9% females are left-handed and 11% males are left-handed. So left-handed is what? It's something common. The C event C is, let's say, left-handed, and that is common to both the populations, right? For example. So now let's picturize this one. Think about this one as, so actually this is, in this way it is better, which I feel, and that's why I show this Venn diagrams. Like yeah, so let's say there are this populations. Now I can say that this population is divided into two, right? So let's say this is 45%, which is female, right? And that shows a probability, right? And let's say this is 55% male. So if I choose one person randomly out of this population, then what is the probability of it is female?
45%.
Yeah, that is what 0.45, right? And probability of male is 0.55, and that is evident, right? That is evident from whatever the information given to us. One more thing is, are they disjoint? Yes.
Yes.
because there is nothing common, right? So a female cannot have, like, it can be female or it cannot, like, they both cannot share anything, right?
Yes.
A female cannot be a male and a male cannot be a female. So that's properly defined. Now
Yes.
left-handed. So there is one event C. So let's say I define one event A as a person is a male. Okay. Or maybe maybe this is better. Person is male. Okay. F is person is female,
Hmm.
right?
Yes.
And let's say one more event as L, which shows a person is
Left-handed.
left-handed. So you can say that there is clearly a portion, something like this, right? Which is L, okay? And it
Yes.
says, okay, sorry, where is the question? The question is here. It says that 9% are, like, among all the females, 9% are left-handed, and among all the males, 11% are. So what is actually percent? So you can think of this as like how many female are left-handed. So that is probability that a person is left-handed given that it's a male, it's female. So that is
9% or 45%.
9%
Or
of
45%.
45%, right? So how much I don't know. Like, can if someone can okay, maybe I'll keep it as it is here. But this is correct, right? This is the conditional probability. Are you okay with this?
4.15%, I guess.
Okay, whatever the answer is.
0.415.
But is it correct? Like whatever I have written is correct or not? Probability of
Yes.
it's left-handed given that female. Is it correct or no? I think no,
Yes.
right? No, this okay. This statement is wrong, right? That this 0.909 into 0.05, I think that is probability of this one.
Oh, okay. Yes.
Correct?
Yeah, correct. Sorry.
Probability that a person is left-handed given a female is 9%,
Hmm.
right? So and what is the conditional probability formula? Left-handed given female is probability of intersection female divided by probability of female, right? So if I wanted to find probability of L intersection F, which is this portion, right? How will I find it out? Probability of L intersection F is equals to probability of F into probability of L given F, right? Which is nothing but 0. So what is probability of F? Probability of F is 0.45. Probability of male is 0.55. So it's 0.45 into 0.09, right? This is what it is here. Okay, this is clear,
Yes. Yes, ma'am.
right? I think that's fine. So similarly, if I wanted to find what is probability that L given L intersection M male, so this probability I can find it out by using probability of male into probability of maybe L given M, right? And L given M is how much? It is 0.11, and into probability of male is 0.55,
5.
right? And this probability it shows here. This is here. Okay, this clear, right? Okay, so leave about these things. Now tell me what is the question. The question is, if a person is randomly chosen from the population, then what is the probability that the person is not left-handed? Okay, this is good, right? So not left-handed means which portion actually we are targeting about here?
Yeah. The non-shaded portion.
Yeah, so outside everything, right? Right. But how to approach to this answer? Again, so let's say I know, okay, so if I know what is the probability of left-handed, then what is the probability of not left-handed? It's a complement event, right? So can I write it as 1 minus probability of left-handed?
Yes.
It's fine, right? So let's calculate what is the probability of left-handed persons. What does that mean? Which portion? This one, right? The intersection portion, right? So can you tell me what should be the answer there? So this is nothing but equation 1 and this equation 2, right? Adding these two, that will give me the probability of left-handed. So probability of left-handed is nothing but probability of, this is total probability of male into probability of left. Okay, maybe I'll write in this way. Probability of left-handed is nothing but probability of left-handed intersection male plus probability of left-handed intersection female. Now I can write probability of left intersection male as probability of male into probability of L given M plus probability of female into probability of L given F. So what is probability of male? It's 0.55. What is probability of L given F? M, it's 0.11 plus probability of female is 0.45 and probability of L given F is 0.09. So this is probability of left-handed person, right? So if I wanted to find probability of not left-handed person, it's 1 minus P of L. If you can calculate and tell me like if this is correct answer or not.
Sir,
Hmm.
there's a request from our side, sir.
Yeah.
Can you share the previous question paper, sir, from the December month?
I do not have the question paper currently with me, but maybe I'll share. So I'll share this PDF with all of you, whatever the questions, those questions which I'm, explaining, and then I'll share that one also. Fine.
Sir, can you please share a question paper also, sir? Because it will be a
Sure, sure,
little helpful for her.
sure. Yeah,
Sir,
will do.
and another query, sir. Can you tell about important topics from all of the units? It will be a little easier for us to prepare, sir, if you can.
Actually, all the topics are important only. That's why we, yeah. But
I mean, sir, in like a general note,
yeah.
can you
So
tell, sir? Not more than that.
okay, maybe what I'll do is maybe I'll send you guys an announcement regarding the weightages of weeks, like from week 1 to 4, 5 to 8, and 9 to 12. In that announcement, I'll tell you what is the weightage which is coming into the end, that qualifier paper. Will that be okay?
Yes, sir, that is okay. And on a general note, please tell us the important topic, sir, if it is okay with you.
Yeah, I'm okay, but I currently, so the problem is I haven't seen the weightages of the the question paper. So I have prepared the paper, but I didn't check the which portion is coming where. But let's say I'll tell you, like, maybe what you can target is maybe if you are good at probabilities, so most, like, some of the questions will be coming from PNC. Okay, that is permutations and combinations. You can think about some problems with simple probabilities. Okay, and if you are not comfortable with conditional probability of Bayes theorem, you may I'll ask you to skip that portion. If any question is coming, you just skip that portion, because most probably only one question will be coming from that uh, portion. It may come or it may not come. So conditional, because lot of people will find it difficult. So conditional probability or Bayes theorem, you can skip. But at least the probability portion, which is like normal probabilities, right? Like for example, we have seen that in terms of or like probability of A is given, probability of B is given, how to find probability of A union B. These probabilities you should answer. Permutation combinations, you just do it like properly, because maybe 3 or 4 questions will be coming from P and C. Probability is important. Conditional probability you may skip. Conditional probability of Bayes theorem. You may think about the distributions. So discrete and continuous. Continuous mostly think about uniform and exponential. I will take the 2 questions from this portion, uniform and exponential, and this is very easy topics to study about. So it's very easy. Discrete distribution, you may think about Bernoulli, binomial, and geometric. I think that is enough. These three distributions are enough, and these two distributions are enough from. And this is like this will cover mostly week 11 and 12. Okay, from 9 and 10, you should understand what is a distribution, right? What is a random variable? Maybe I'll talk it a little bit about this random variable, expectation, and variance. Okay, I'll tell you, and this is mostly about discrete one. It's not about the continuous one, it's discrete one. Okay, fine. uh, and you can go to week 1 to 4. This is important. Week 1 to 4, mostly the topics of mean, median, mode, correlation coefficient, these are important. So our practice about the correlation coefficient, because it will have a lot of calculations involved. Mean, median, mean at least go through properly. Mean, median, and mode, I will say. Yeah, I think, and that is both for categorical and numerical. Okay, so I'll tell you that permutation combination, revise the questions, like solve more number of questions, probability solve more number of questions, continuous distribution, uniform and exponential, just go through that. It's very important. Uh, from 9 and 12, I'll tell you like what are the important topics. I'll solve 1 or 2 questions from that topic. Then you'll feel confident about week 1 to 4. I'll suggest that go through all the syllabus once, because those are like simple, and you can maybe in 3 or 4 hours also you can complete all these topics from week 1 to 4. Okay, so maybe I'll just go through, okay, the random variable topics first, so that
One question. Uh,
Maybe so in the
yeah,
previous question, I mean, I can you
yeah,
solve it? I think actually the total sum of it is coming greater than one
no, no,
according to
oh,
my
is it,
calculation.
is
Sorry,
I don't think
I'm
so.
subtracting it. So
Okay.
Sir,
Mm,
one more doubt.
yeah,
Where will you share this PDF and the other
mail, 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 mail.
and the previous year question paper also, right?
Yes.
Okay,
Sir,
wait.
sir, can you share it in this meeting, sir, so that we can start practicing by tonight, sir?
Yes,
Uh,
sir.
okay, I'm not sure like whether I can share. I don't know, like how can I
Sir,
share this one? The PDF, it's a PDF, right?
Sir,
Sir,
there
you can
in the
upload
chat
drive.
itself.
Okay, I can share. It's not a problem for me.
yes,
So,
sir. Because if you share tomorrow morning, again there's a delay, sir. So
Sir, in the chat section, you
no,
can
okay,
upload the document.
okay, fine. I'll just try
So
and
what
do
will
that.
be the weightage of the paper?
I will share that. Actually, currently, I do not. I'm not sure like what is it. Maybe I'll share that with you with the mail. Hmm? Okay, but 1 minute. I'll just share you the PDFs, both the PDFs, so that you can.
So may I know how many questions will be there in a question paper?
Uh, maybe 15. Uh, okay. I'll tell you. Okay, maybe I'll tell you just a minute. Give me a minute. I'll tell you exactly the numbers.
And what's the weightage of a paper?
Okay. Wait is I need to calculate. Just a minute.
Okay.
Don't worry about it. It's not a difficult paper anyways. Uh, just give
So
me a minute. Maybe I'll tell you exactly what is it.
actually, sir, after solving the mock test paper, we are just They are so difficult to solve these papers, and I think
Okay, I'll tell you. Okay, so the probability questions. So if I take the 50 marks questions, I'll tell you exactly. So you can able to find the relative frequencies and frequencies, right?
right.
Frequencies and relative frequency. So that will cover around, maybe so first 4 weeks that will cover around 3 9. Okay, 1 minute. I'll tell you exactly. Okay, so there are total of 14 questions in the paper. Okay, uh, then you can think about like 20% of the weightage is for week 1 to 4, and that will mostly cover that frequency is relative frequency. What is range, median, that percentiles, right? Percentile. I think Prashant has covered that one. Percentile calculations. So it is 25th percentile, 50th percentile, IQR, those things has to be covered. So just practice about that little bit. Then you can think about this permutation combination problem. So it is like around, yeah, around 15% will be from permutation combinations. Then you can, yeah, probability will cover around, 10%, something around 10%, and the last topics. So yeah, conditional probability, it is there, but I told you, like, if you find it difficult, just skip it. No issues, right? About, and then you can think about the last 2 weeks, right? So last 2 weeks will have around, the remaining portion, maybe 3, yeah, around 20% for last 2 weeks.
So it must be 2 to 3 questions from each unit, right? Or maybe 1 to 2 questions.
Yes. Okay. Are you able to see my screen now?
Yes, sir.
No, sir.
Yes or no?
No, sir.
I'm not able to see, sir.
No, sir. Screen's not visible.
Yeah, fine.
Now it's visible.
Now
Okay.
it's visible.
So yeah, okay, fine. So I was talking about, this is the correct answer, right? So if I see this probability of left-handed is equals to 0.11, and this has become 1 minus 0.11, and I think it is 0.89, right? So I think that is the correct answer. You see, it's 0.899 something is written here. Okay, so maybe I'll go directly to, we don't have much time. So let's talk about the distributions. The random variable, maybe you can study later. Okay, yeah. So you can think about this. All of you got the questions, right? Hello.
Yes, sir.
Okay. So maybe I'll discuss a little bit about random variables, and then maybe I'll give you the formulas for the distributions. Or do you want me to solve the, so because I have like 20 minutes left. So what do you like? Should I describe random variables first, or discrete and continuous? You wanted to solve some questions from discrete and continuous random variable distributions, maybe. If you are okay with the random variable stuff, skip this one, skip this part.
So permutation and combination.
Permutation combinations is already done, right? Like previous classes. And today also I solved some questions, no? Permutation combinations.
Yeah, sir. I have so many confusion. Uh,
permutation combination you will have like always you will have something here. Okay, so that is like the correct way is I will say go to the basics where additional principle and counting principle, and then try to solve like more number of different questions. Then only you will be able to know have like confidence in it. Otherwise it will always you nobody can actually tell about permutation combination that I will solve this correctly.
Okay.
Like this is kind of like that. Okay, so
Sir,
But
maybe
can we
today the
solve
questions
random
we did,
variable?
yeah.
so today the questions we did from permutation and
Okay,
combination, those type of
maybe
questions will
maybe
become
without yes, yes, you can think about that only. You can think about those type of questions. Okay.
okay.
Okay. So the question number. So let's say what is random variable? You have already told, right? Like it can be. So suppose if I toss a coin, right? If I toss a coin, what are the outcomes there? Head and tail. And if it is unbiased, then the probabilities associated with it are 0.5 and zero point 0.5. So suppose x is a random variable. I say it is what? Let's say I say it's getting a head in a toss of coin, toss of fair coin. Okay. Then what I'll get like here head is what? Head is my success. So suppose I represent head by 1 and tail by 0. Okay, so what are the values taken by head and or random variable x? 0 and 1. So what are the probabilities associated with these values? So this represents head, this represents tail. What is the probability of coming head? 0.5 and coming tail as or getting tail as 0.5, right? In tossing a coin. So this is the probability mass function of a random variable. Okay. What are the properties of probability mass function? One property is each of the probability, right? Each of the individual probability, it should be greater than or equal to 0. That means it should not be negative. Second one is the sum of
Sum should be
all
1.
the probabilities. Yeah. So here you can say the probability associated with x equals to 0. So probability that x equals to 0 is 0.5 and probability that x equals to 1 is 0.5. So both these probabilities are non-negative and the sum is equals to 1, right? These are the properties of PMF or probability mass function. Okay. So now okay, so we can have any random experiment and we can have number of values taken by the random variable and the probabilities associated with it. For example, if I take one more example as suppose I throw a die and the outcomes are for example 1 2 3 4 5 and 6. Okay, let x be a random variable of, let's say, getting an even number. Then how can I write down this PMF? So getting an even number is my success. Okay, so I'll represent this by 1, and not getting a even number is my failure.
So
So
your
that I'll
screen is
represent it by
stuck
0.
for
So what is
us.
okay? Okay. Are you able to see this now?
No, sir.
See, are you not able to see the screen? Okay. Uh, Now?
No, sir.
Okay. Okay, I'll join again. Let's see. Okay. Is it visible now?
Yes, sir.
Okay. So suppose if I roll a die, what are the outcomes? 1, 2, 3, 4, 5, 6. And if I say my random variable is x, which is getting an even number. Okay, so I define x equals to 1 when I say when I get an even number. Okay, and 0 when I get odd number, right?
Hmm.
What are the probabilities of uh, x associated with this? So suppose this is a fair die. So what are the probabilities of getting 1 by 6? So each of them are 1 by 6, right? So what are the so when I say x equals to 1, that means what is this event? This is an event of getting 2, 4, and 6 on the die, right? And then the probability will be what? It's 1 by 6, 1 by 6, and 1 by 6. So it's one, either I'll get 2 or 4 or 6. So these probabilities will add up. So that will become 3 by 6, which is nothing but 1 by 2. So this is 1 by 2, and this is 1 by 2. Right? This again becomes a Bernoulli trial, right? Bernoulli random variable. So uh, this is the PMF of x. Okay, and when x is what? Getting an even number. So this is the general representation of PMF. Another way I can represent it as like this: probability that x equals to x. I'll get the probability half when x is even, or I'll say x equals to 1, and 1 by 2 when x equals to 0. And this 0 and 1, this is called the range of x. Range of x, or the values taken by a random variable x. Okay. So if this is clear, uh, yeah. So now this is the random variable x is given, and its probability distribution function is given to us. What we have to find is we have to find probability that x equals to 5. So what are the two properties of random variable, or not random variable? What are the two properties of probability mass function? They should be non-negative, and the second is what? The sum should be equals to 1. The probability sum should be equals to 1. So in this case, I have to add what? Probability that x equals to 1 plus probability that x equals to 2 plus probability that x equals to 3 plus probability that x equals to 4 plus probability that x equals to 5 is equals to 1. Okay. So probability that x equals to 1 is what? 0 plus x equals to 2 is t plus 3 is t by 2, 4 is 4t square, 5 is 3t by 2, and this is equals to 1. Okay, so let's find it out. So it's 3t by 2 plus t by 2 is 2 plus 3t, so 3t plus 4t square equals to 1. Okay, so this is a quadratic equation, so I'll get two values here: 4t square, let's say, plus 3t minus 1 equals to 0. Can you tell me what values t can take?
So 1 by 4 and minus 1. So minus 1 will not be there. 1 by 4.
1 by 4 and minus 1.
Minus 1.
Okay, so we can neglect this, because if I put t equals to minus 1 here, right, this probability becomes non-negative, right? So in that case, I can skip this one, and I'll have t equals to 1 by 4 as a correct value. So this probability mass function will look like what? So this will, let's say, 1, 2, 3, 4, 5, and the probabilities will be 0, 1 by 4, 1 by 8, it's 1 by 16, so it's like 4 will get cancelled, so it's 1 by 4 and 3 by 8, correct? And you can check, you will get equals to 1, right? So sum of all probabilities equals to 1. What we need to find out is probability that x equals to 5. So what is probability that x equals to 5? It is 3t by 2, and which is nothing but 3 by 8. So option C should be the correct option. One more thing about PMF is or random variable is we have to find the expectation of random variable. What is expectation? It's a long-term average of any random variable. So it is generally given by this. summation of, so this is what I am talking about, discrete random variable. Okay, discrete random variable. So this is summation of x into probability that x equals to x. So if it was not a discrete random variable, if it is a continuous random variable, in that case, what is the expectation formula? So it is expectation of x equals to integration x into px dx, and that is px means it is PDF. Okay, and this px is what? This is PMF, right? What is PDF? Probability density function. PMF is probability mass function. So in this case, what is the expectation of x? So this is x, is probability that x equals to small x. So expectation of x is equals to what? 1 into 0 plus 2 into 1 by 4 plus 3 into 1 by 8 plus 4 into 1 by 4. So if you can do these calculations, I have to check. So 1 by 2 plus 3 by 8 plus 1 plus 15 by 8. I don't know. So it's like 4 plus 3 plus 8 plus 15 by 8, 15, 8, 23, 26, 30, 30 by 8. 30 by 8 is what? 4, 15 by 4, right? So this, yeah, 3.75. So expectation of x is 3.75. Just think about it for 2 minutes and then we'll discuss more. Okay. So yeah, so let's okay, the CDF is there, so I'll talk about it a little bit. CDF is what? Cumulative distribution function. Maybe I'll, okay. So we have this random variable with us, probability that x equals to small x, 1, 2, 3, 4, and 5 is 0. I think it's 1 by what? 1 by 4, 1 by 8, 1 by 4, 4, and 3 by 8. Okay, so we have found out expectation already. So maybe we can find it out. What is CDF? CDF is what? Probability that x is small x, and this is shown by this letter f of x. Okay, probability that x, capital X is smaller than x. So what is this small x? This is the values taken by a random variable. Okay. So in this case, if I wanted to find the CDF for this probability mass function, how will I find it out? So f of x is equals to yeah. So it can be like, can think of, this is cumulative distribution function, right? This is cumulative distribution function. So in this case, it should be yeah, when x is less than 1, it is 0, right? When x is equals to 1, or maybe I can say when x is equals to 1, what is probability? Uh, it is 0, right? When x equals to 2, it is 0 plus 1 by 4. That is what? Okay, what is f of 2? F of 2 is probability that x is less than or equal to 2. What does that mean? It is probability that x equals to 2 plus probability that x equals to 1. So probability that x equals to 2 is what, how much? It is 1 by 4 plus probability that x equals to 1 is 0. So it is 1 by 4. I will write it down as 1 by 4. What is probability that x equals to 3? It is probability that x equals to 3. Or what is f of 3? It is probability that x equals to 3 plus x equals to 2 plus x equals to 1. So that nothing but 1 by 4 plus 1 by 8. So that is 3 by 8, right? 3 by 8. X equals to 4 is what? Yeah, 3 by 8 plus 1 by 4 now. So it's 5 by 8, and x equals to 5, it is how much? It should be equals to 1. So this is CDF of this function. You can think about it like this, like I'm adding all the probabilities, and if you see, if you draw it, and at the end it should be equals to 1, right? And that is true for PMF, right? Because if you add all the probabilities of the PMF, that should end up into 1. So the CDF will be the final the for the final value of in the range, it should converge to 1. Okay, for all the values greater than 5, I can say for all values greater than 5, it should be 1. Okay, for x greater than 5, it is 1 only, and for x less than 1, the probability should be 0. So that is understood. So we are not writing this for discrete random variables. Generally we do it for continuous random variables. Okay, fine. So yeah, let's, maybe we do not have much time, so let's talk about some discrete distributions and continuous distributions. So first of all, discrete distributions are what? I'll talk about three discrete distributions and their formulas. So one is Bernoulli. You may have to solve the problems for this. So I'll just write down what are the PMFs or of them, or what are, how to find the probabilities for by using the Bernoulli for this distribution. So for Bernoulli, the probability mass function is like this. So it is yeah, uh, yeah, some p for x equals to 0 and 1 minus p for, or I can say for p when x equals to 1 and 1 minus p for x equals to 0. So what is the expectation of the Bernoulli random variable? It is 1 into p plus 0 into 1 minus p. So this is equals to p. Okay. What is the variance of Bernoulli random variable? So we didn't talk about the variance, but its variance of any random variable is expectation of x square minus expectation of x to the whole square. Okay, so you just find it out by using this formula. Okay, and yeah, so if I wanted to find for this, so what is expectation of x square? It is nothing but x square into probability that x equals to small x is summation of, right? So in this case, it is x square is 1 square into p plus 0 square into 1 minus p. So again it is p. So variance of x is p, right? The standard deviation will be the variance of square root of the variance. So this is nothing but p again. Okay, this is Bernoulli random variable. I'll talk about maybe binomial random variable. Binomial random variable is nothing but the IID distribution of IIDs independent identically distributed Bernoulli trials for the fixed number of trials. So there are two uh, okay, there are two parameters for it. So n into p, n is what? These are the fixed number of trials, and this p is the probability of success. Okay, so for this actually I'm just like I'm just taking it like too fast because we don't have much time, but you can refer to some other videos of mine. Maybe previously you'll get it on IIT Online Degree, that page on YouTube, or maybe you can refer to any other standard book, or maybe any internet resource for this. Okay, so binomial distributions, the PMF is provided that it is given by this NCR p to the power r and 1 minus p to the power n minus r. What is r? R is the number of successes in n trials. Okay, I'll talk about this a little bit. So what is it? So for example, if I toss a coin 10 times, okay, so there are 10 experiments, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And if I toss a coin, so we have like head and tail, right, on each coin. So every trial will have two outcomes, either head or tail. Every trial will have head or tail. So I wanted to find, and there are n equals to 10, right? There are 10 fixed trials because I have tossed this coin for 10 times. So here n equals to this 10 are the number of fixed trials, right? So these 10 trials are fixed. In that case, I wanted to find how many successes, maybe 5, or maybe let's say 6 heads. So I define head as a success here. So I wanted to find what is the probability that I will get 6 heads in 10 trials. So that will be probability that x equals to 6 is nothing but 10c 6, because I am choosing 6 places out of this 10 into what is probability. Suppose this is a fair coin, so it's 1 by 2 to the power 6, right? That is the probability of getting head, and 1 by 2 to the power 10 minus 6, which is nothing but 4. And so if I do this, it is 10c6 into 1 by 2 to the power 10. So this is how you can find out the probability for binomial random variable. What is the expectation of a binomial random variable? It is n into p. You can actually remember this, it's not difficult. It's expectation of x is n into p. Variance of x is n into p into 1 minus p. Okay, what is p here? P here is probability of success. N is number of fixed trials. Okay, after that maybe I'll talk about this one. uh, yeah, two distributions. Okay, are you guys there, or do you just left off?
Yes, sir.
Yeah, okay, I'm just going so fast, I know, but in general cases I will like spend like more than 2 hours on this, but it's like, yeah, we don't have much time, so I'm just doing it fast. Okay, so maybe the third case is geometric. We will have Poisson random variable also, but I'm not going to talk about this today. So I'll just talk about these three from the discrete distributions, and then I'll talk about two continuous distribution. Okay, so geometric is what it is. It is again the similar that of as that of Bernoulli and binomial, but the difference here it is we are thinking about the first success in like infinite number of trials. For example, if I wanted the first head uh, in fifth trial, okay, what does that mean? So I have tossed a coin like fifth, like maybe like how many number of times I have tossed a coin, but I observed first head in the fifth toss. What is the probability of getting that? So that means in the first 4 tosses I got tails, right? So suppose if this is the case, then let's say there is a probability of p associated with getting a head and 1 minus p associated with getting a tail. Then the PMF for the geometric distribution will become yeah, how many times it is, like, and so it is 1 minus p to the power 4, because this is 1 minus p, right? So this is 1 minus p is 1 minus p, 1 minus p, 1 minus p for the first 4 tries, and at the end it's p. So the generalized formula is probability that x equals to x is 1 minus p to the power, let's say, or maybe I'll say r here. So it is 1 minus p to the power r minus 1, okay, into p. This is my PMF for the geometric distribution. Okay, you can actually, you need to know about this only. You need not to know about the expectation and variance of the geometric distribution as of now. But you can actually, if you are interested, you can go through that. Okay. Then I'll talk about some continuous random variables or continuous distributions. So continuous distributions are, I'll talk about two. One is uniform, and then I'll talk about exponential. Okay, so uniform between some interval a and b. So suppose something is uniform in between a and b. So for example, if the player is playing a game and the times he is spending, or maybe the video game, and the time he's spending the video game is uniformly distributed between 20 minutes and 30 minutes, then and I said if it is uniformly distributed, in that case, what is the probability? So when I talk about continuous distributions, I have to talk about PDFs, not the PMFs. So it is probability density functions. Okay. So probability in case of, yeah, and in that case, I have to just write it down like this. So actually, okay, there are two notations. This is f of x. This is called as PDF, and for uniform distribution, it is 1 upon b minus a. Okay. What about CDF? CDF is what? CDF is nothing but probability that x is less than or equals to x, right? So that means I have to integrate this PDF from minus infinity to x for f of x into dx. So in this case, it will be minus infinity to x 1 upon b minus a into, or yeah, let's talk about this. Let's say, yeah, uh, yeah, fine, that is it. So it should be like this. So this is like x, and okay, again, so it is not from minus infinity to x, right? Because this is between this interval a and b, so I can disintegrate this between minus infinity to a, 1 upon b minus a into dx, plus from a to x 1 upon b minus a into dx. So this is 0 because within this interval this is uniform, outside it is equals to 0. So I'll just have to uh, do this integration, and this will become x minus a upon b minus a, that is f of x in case of uniform random variable, and this is uniform continuous. Again, the expectation of this uniform random variable is what? It is a plus b by 2. And how I found out this? So expectation of x in case of the continuous random variable, it is given by my this formula, right? X into fx dx. So here I have to integrate between plus a to b, because minus infinity to a it is 0, and b to infinity it is again 0. So I have to integrate between x into 1 upon b minus a into dx. So 1 upon b minus a is, that is constant. So this is x square by 2 from a to b into 1 upon b minus a. So you can think about this as a square plus, or maybe I can say b square plus a square by 2 into 1 upon b minus a. So here a square plus b square, I can write it as a plus b. Oh, sorry, this b square minus a square. So I can write this b square minus a square as a plus b into a minus b divided by 2 into 1 upon b minus a. So a plus b, and can write it as like b plus a into b minus a, right? Because this is b square minus a square. So this it will get cancelled, so it becomes a plus b by 2. So this is expectation of a uniform random variable. Okay, so variance actually you need to find it out by like using normal formula, that is expectation of x square, and you can find it out like later on. Okay, so variance of x here in this case, it should be expectation of x square minus expectation of x to the whole square. So expectation of x already we have found out here. Expectation of x square, how to find out? So you have to just integrate between a to b for x square into f of x dx. So it is here, it is 1 minus b into dx. So that is not needed, but if you are curious about it, you can find it out. Okay. Then next one is I'll talk about exponential distribution, and it will have parameter lambda. Lambda is generally its inter-arrival rate, and yeah, you can so PDF of exponential distribution is given as, so I'll write it this way. F of x is lambda e to the power minus lambda x. Then in CDF is given as 1 minus e to the power minus lambda x. How to find the CDF of this? Integrating between 0 to infinity, because the range of exponential distribution is, or exponential random variable is from 0 to infinity. So we have to integrate between 0 to infinity. What is it? This one, right? So lambda e to the power minus lambda x into dx, and if you integrate this, you'll get this answer. Okay. What about expectation of x? So expectation of this one is 1 upon lambda. Variance of x is 1 upon lambda square. Okay. So that is it. These are the formulas which are important. You can just solve the questions. Yeah, maybe you can stop now. I already shared you that thing. Okay, this I haven't solved the problems, I know, but you can for this, this type of distributions, you will get the questions and solutions available on the internet, or you can watch my lectures or any one of us lecture from the statistics team about week 9 to 12. Any revision session, you can find it out and you can just see the answers there, right? Okay, so I'll try to share you guys the question paper, maybe previous year question paper. Okay, that's it from my side. Okay. I hope you enjoyed this. I know it's a bit faster at the end, but yeah, we don't have much time to
Yeah, thank you,
spend on,
Mayor. Thank you, Mayor, for the
right?
limited time that you
Yeah,
got. But yeah, it was a great session.
yeah. Okay, guys, thanks a lot. Maybe we'll stop this session. Okay, thank you for joining. It's more important that you guys have listened me patiently. Thanks,
Sir,
guys.
can you share the
Bye.
previous year question paper?
Sir, there is one
Yeah,
there
yeah.
was one doubt.
I'll
Could you
share
please
you
solve
that.
it?
Yes, tell me. I need to solve the question.
Yeah, sir. I have tried it multiple
Okay.
times. I'm not
Okay,
able to
fine.
get the answer.
Yeah,
Can I
yeah,
screenshot
fine.
the
Just let me know. Yeah.
question?
Yes, fine. Yeah, yeah, this is fine.
Hold on.
Hello, sir. Sir,
Yes.
sir, I had a basic question about the difficulty level of questions. Like, what will be the difficulty level? Like the mock exam papers or like the today's questions?
Maybe see, mock exam paper is, I think, a fairly difficult one, but it won't
Yes.
be that much difficult. Okay.
Okay.
So
Okay,
it
sir.
won't be that much, but it's better that if you try the mock questions like properly. So see, if you go for the difficult ones, maybe you'll be able to solve the easy ones, right? So that is the idea. Okay.
Okay, sir.
Okay, I'm not able to see the question. Let x be a discrete random variable, and okay, I'm not able to see this, like it's very little small letters actually. So that EMF is what? Okay, okay, maybe okay. I'll try. Yeah, copy this one. Fine. I'll solve this one. This is a good question actually. Okay. This is a question, right?
Yeah.
Let x be a random variable. Yeah, discrete random variable in the following PMF, there exists this point value of k. Okay. First of all, if this is a PMF, then what is the property of it? The summation of all the probabilities
Equal to 1.
equals to 1, right? So I will use that one only to solve this problem. Okay. So let's say, and what are the values taken by random variable? 0, 1, and 2,
2.
right? So
Yeah.
I'll draw the PMF table first. Okay. So yeah, so what is, so 0, 1, and 2. Okay. So what is probability that x equals to 0? It is k into 3c0 divided by 3c3, right? What is 3c0? 3c3 is 1, 3c0 is
1.
1, right? So it is k, right? So I'll write in the down as k. What is probability that x equals to 1? Is k into 3c1 divided by 3c2. So 3c2 and 3c1 is what? Correct, same only, right? This will get cancelled, right? So 3 by 3. Again, it is k here, right? What about probability that x equals to 2? It is k into 3c2 divided by 3c1. Again, these are cancelled. This is in k. So if I use the probability mass function properties, which is k plus k plus k, which is 3k, is to 1, right? And k equals to 1 by 3, and I think 1 by 3 is 0.66 or yeah, 0.66. Oh, sorry, yeah, 0.3, sorry, 0.33 or maybe 0.3, right? Let's check whether this is correct answer or not.
Actually, sir, in the sample question, the answer they have given is 0.5. So that's why I got the same answer, 0.33.
Oh, okay. No, 0.5, I think that is wrong. 0.34 is the correct answer. Okay.
0.33
Right?
is the correct answer, right?
Correct. Yes.
Okay, so thank you so much, sir.
Okay. Okay, guys, then bye bye. Good night. All the best for your exam. Yeah, good night. Bye bye.
Sir, can you please share the question papers here if possible?
Here it's not possible because I need to find that one. It's not there like with me currently. So I'll share that with you by mail, right? Okay. Sure. Bye.
Thank you, sir.
Sir, how will you share the PDF, sir?
Sir left, I think.
Did he tell how will he share?
He told he will share by mail.
I think by mail, everybody will be receiving some mail or something.
They don't have our mail IDs, no? Then how?
No, they have. That is how we are getting the hall ticket. You have received the hall ticket, right?
Anyone solved question number 6 of sample paper?